Well, hello. I haven't done this since COVID, so I hope I'm not too rusty about giving you the answer to this question. So, this graph represents the number of bacteria growing over time, and the first question is asking find the number of bacteria at 40 minutes, and that's just reading off the graph. So you can see at 40 minutes, if we read up the graph and read across, the number of a bacteria is 4,000. So you can say that y equals 4,000 for the first part. Okay, now the second part of the question is the one I guess that you were struggling with. It's saying that the equation of this graph here is in the form y equals a times b to the power of n, where a is a constant and b is a constant. Now we know that a is the initial population of the bacteria, so we can write down our equation as being this: y equals 1000, because the graph cuts here at 1000 when t equals 0, okay, times b to the power of n. Now they want you to use the guess and check method to work out what the value of b will be. Okay, then they actually want an upper and lower limit for the value of b. We'll talk about that in a minute. But to get the value of b, we already know that when n equals 40, y equals 4,000. So if we put those into our equation and write this down, 4,000 equals 1,000 times b to the power of 40. Now that's the equation that we need to solve using the guess and check method. We can solve it without the guess and check method, which I'll do at the end, but the guess and check method is basically substituting numbers into the calculator to give us our answer. Now, where would we start? Well, if we notice that if we had b equals 1, for example, if we had b equals 1, then 1 to the power of 40 is going to be 1. So 1,000 times 1 is going to be 1,000, so it's going to be too small. b equals 1 is going to be too small. If we said, well, let's try b equals 2. 2 to the power of 40 is God knows what. It's very large. Okay, so something very large times by 1,000 is even larger. So it's going to be something between 1 and 2, very close to 1. So my first guess would be b equals 1.1. So all you would do is go to the calculator and type in your equation, which would be 1,000 times 1.1. I even think that's going to be too big, to the power of 40, and that gives us 45,000. So it's way too big. So how about we try and even delete that 0.1, and let's try 0.1. So whoops, 0.01. Now that gives us 1,400, which is a little bit small. So why don't we jump up, and I'm going to write this one down. b equals 1.03. And we'll see how we go with that. Get the calculator back, arrow back, change that to a 3. And 3 gives us 3,262. Okay, so let me write that down there. Y equals 3,262. Why don't we try just one up from that? 0.4. Y equals, grab our calculator, And delete the 3, change it to a 4, and that gives us 4,801, which is a closer approximation to what we wanted. So let me write that down, 4,801. Now, we could go on and get a closer approximation, because that was 3,000, that was 4,800. It's sort of halfway between that. But according to the question, we want an upper and lower limit of the estimate, and it must differ by 0.1, which is essentially what we've got here. So that would be your answer. B would have to lie somewhere between 1.03 and 1.04. That's essentially the question, the answer. Okay. Now, if you wanted to get the accurate answer, very simply, you would say, well, I've got my equation here, which is 1,000 times b to the power of 40 equals 4,000. Now I'm going to remove the 1,000 on this side and move it over to here, so it'll be b to the power of 40, so it'll be 4,000 over 1,000. That would simplify to be 4. Now to change b to the power of 40 to b, we've got to take the 40th root. Okay, so it'll look like this. B to the power of 40. The 40th root looks like this, with a little 40 there. But you would have to do the same on both sides. 4. So you're taking the 40th root of 4 to get your answer. So b would equal, and we'll get our calculator up once more, and we clear that, and we go to here, put 40 in there, arrow down, put 4 in there, and you can see we get an answer of 1.035. Lost my pen. Of course I have 1.035, which you can see is halfway between these two here. But they don't want you to do it that way. They want you to do it the guess and check way. You could do it this way first, find out roughly where your number is, and then do your guess and check and show them the guess and check doing 1 above that, or 0.01 above it, or 0.01 below it to get your range of values. I hope that was helpful.